11-9, which is all about spheres. So first of all, we went over in classifying them that a sphere is a ball. I mean, you really can't get any simpler than that. But your parts of a sphere, you've got the diameter, you've got a radius, you've got the center, and then my personal favorite, you've got the great circle. If you've ever watched The Great Pumpkin, Charlie Brown, that's what goes through my head every single time I have to say the great circle. I feel kind of like an idiot. But a sphere is a solid in which each point is equidistant from a center point, and the great circle slices the sphere into two hemispheres. So if you're talking about the great circle, picture a perfectly round watermelon. You slice the watermelon in half. Well, that means you've got kind of a wonked up shape. You've got one of these where this top layer is an entire circle. That's your great circle. So you've got surface area and volume of a sphere, your volume formula, 4/3 pi r cubed, your surface area, 4 pi r squared. I think one of the easiest ways to remember this is volume is cubic units, which means you've got a cubed and you've got a denominator of 3. So the 3 should kind of help remind you that that's the volume, whereas surface area is only units squared. Therefore, you've got the square, and the 4 belongs to both. So number 1 wants you to find the volume of each sphere below. You need radius on both formulas. Number 1, you're given the radius. It's 7. All you got to do is plug and chug. Plug it into the formula. You get 1,436.76. These are by far the easiest equations we've done so far. Number 2, same thing, except that it gave you the diameter. Again, we never need the diameter. We divide that by 2 to get our radius. Our radius is 16.5. Plug that in. 18,816.57 cubic centimeters. Really straightforward. Number 3 and 4 wants the surface area. Again, all you need is the radius. If you notice on 3, your radius is drawn kind of differently. So up here, you were given, center straight across. Now you're given center down at an angle. It's still a radius because all of the points around your sphere are equidistant from that center point. Your radius is 2.8. Plug it into your 4 pi r squared formula, and you get 98.52 meters squared. Number 4 is very similar to number 2 in the sense that it gives you a diameter. We don't need the diameter, we need the radius. We divide that by 2, and you get a radius of 12. Plug it in, 4 pi r squared. You get 1,809.56. Then you've got hemispheres. Hemispheres are, half a sphere. Your volume of a hemisphere is 2/3 pi r cubed. Your surface area is 3 pi r squared. So if you want to find the volume of the hemisphere, again, if you notice, the only piece of information you need out of either one of these is your radius. So your radius in this case is 5. Plug it in. You get 261.8.